Hello everyone. In today's lecture, we are going to learn how to find the trigonometric functions of any angle. In previous lectures, we learned how to calculate the trigonometric ratios of certain special acute angle and the right angle. For example, the 0-degree angle, the 30-degree angle, the 45-degree angle, the 60-degree angle, and the 90-degree angle. In radian measures, they corresponded to 0 radians, pi over 6 radians, pi over 4 radians, pi over 3 radians, and pi over 2 radians respectively. In this lecture, we are going to extend those special angle ratios to find ratios of any angle in the different quadrants of the rectangular plane. Now here's what we are going to cover in this lecture. First of all, we are going to review the different trigonometric functions that apply to any angle. We are going to learn about the signs of the trigonometric functions, and the signs will depend on the quadrant in which a particular angle lies. We are going to learn about reference angles, what they are, how to find reference angles, and how they relate to the special angles we learned so far. And finally, once we have an understanding of the reference angles, we will learn how to calculate the trigonometric functions of those angles. Now here we are going to learn about the trigonometric functions for any angle, which will be a little bit different from what we had learned when we were using the unit circle to find the different trigonometric functions. In a unit circle, the radius was always equal to 1. As you see over here, we have a right triangle in the first quadrant of the xy coordinate plane, and we have the side opposite the central angle theta as y and the side adjacent to theta as x, but r this time is not necessarily 1. It can be any value depending on what value x and y takes. Now, r is also the hypotenuse of this right triangle in this picture. So we can use the Pythagorean theorem to find the value of r given the values of x and y. So what this says here is let theta be any angle in standard position, which is the central angle, and let P have the coordinates x comma y. It's a point on the terminal side of theta. We can find the value of r using the Pythagorean theorem, which is square root over x squared plus y squared. It's also the distance of this line from 0, 0 from the point of origin to the point with coordinates x, y. And once we have the value of r, we can find the 6 trigonometric functions of theta in the following manner. So let's look at sine of theta. When we were dealing with the unit circle, recall that sine of t was equal to y, and that was because r had a value of 1. This time r need not have a value 1. It can be a value other than a 1, and therefore we have to write it as y divided by r. For cosine of theta, it's going to be x divided by r. For tan of theta, it's going to be y divided by x, given x is not equal to 0, otherwise the ratio will become undefined. And then we have the reciprocals. Cosecant of theta will be r divided by y. Again, y cannot have a value of 0 because it's in the denominator. Then we have the secant of theta, r divided by x, which is the reciprocal of cosine. And finally, cotangent will have the ratio of x divided by y. Now let's look at an example of evaluating trigonometric functions. Let's see what information has been given to us. And again, we cannot assume that we are dealing with a unit circle here. R will not necessarily have the value of 1. In fact, its value will depend on the values of the coordinates of the point P on the terminal side of the central angle. So it says here, let P equals 1, negative 3. Those are the coordinates x, y for the point. On the terminal side of theta, find each of the trigonometric functions of theta. First, we have to see where that point 1, negative 3 would be located on the xy coordinate plane. So it says x is 1, that's the positive x-axis, so this is x, and y is a negative value, so negative 3 will be along the negative y-axis. Let's mark negative 3 here. This is negative 3 along the y-axis, and that makes the angle an angle in what's called the fourth quadrant. Here are our quadrants. We go in anti-clockwise direction. Start with 1, and the next one to its left is 2. Next one below 2 is a 3, third quadrant, and then the fourth quadrant is the quadrant below the first quadrant. All right, so here we have the value of y as negative 3 and the value of x is 1. We need to find the value of r, which also represents the hypotenuse of this right angle triangle created by the central angle. And we are going to use the Pythagorean theorem to find the value of r, which is going to be r equals square root over x squared plus y squared, correct? So let's see what we have here. We have r equals square root over x squared plus y squared. X has a value 1, therefore 1 squared, and y is a negative 3. We have to square that and we will get a positive value. Whenever you are squaring a negative value, it should give you a positive value. We have a value of r as square root over 10, correct? That's the value of r. So let's write the values here. X equals 1, y equals negative 3, and r will be equal to square root over 10. Now, given these values for x, y, and r, we can go ahead and find the different trigonometric function, starting with sine of theta. Again, it's y divided by r, so we are going to plug in negative 3 into y and square root over 10 for r, and we are going to end up with a square root in the denominator. Therefore, always remember to rationalize that. So here we go. We have negative 3 substituted for y, square root over 10 substituted for r, and then we go ahead and rationalize that by multiplying both the denominator as well as the numerator by square root over 10 to get a value of negative 3 times square root over 10 divided by 10. Now, this is the first time we are seeing a sine function which is a negative value. Let's look at the cosine of theta. Again, the formula for that is x divided by r. So for x, we are going to plug in 1. R is going to have the same value, square root over 10. Again, we need to rationalize that, and we will end up with square root over 10 divided by 10 for cosine. Now, look at the sign for this ratio. It is a positive value. So sine in the fourth quadrant was a negative value. However, cosine has a positive value, and later on we are going to talk more about the different signs of the ratios depending on the quadrant the angle is at. So in the next slide we are going to talk about the other four trigonometric functions. We are continuing here with the same example from the previous slide. We have the same point on the terminal side with coordinates 1, -3, and then x has a value 1, which is the x coordinate of point P, and y has a coordinate of -3, and we found r, its value to be square root over 10. Now we are going to find the ratios of the tangent, cosecant, secant, and cotangent ratios. Tangent is y divided by x. So we have to plug in -3 for y and 1 for x, and we get a value of -3. So here we note that tangent, like the sine function, also is a negative value for an angle in the fourth quadrant. Let's look at the cosecant ratio, which is the reciprocal of the sine ratio. The sine ratio was negative, so is the cosecant ratio also going to be negative? R has a value of square root over 10, y has a value of -3, therefore the cosecant ratio is negative square root over 10 by 3. The next one, which is secant of theta, is the reciprocal of cosine. Cosine was a positive angle, therefore secant must also be a positive angle. Let's make sure it is. The formula for the secant is r over x. R is square root over 10. X is +1, so we end up with a positive ratio for secant in the fourth quadrant. Cotangent of theta is r divided by y. Now tangent was a negative ratio. Cotangent should also be a negative ratio because it has y in the formula, and the value of y is negative as the coordinate of P, correct? So r divided by y is -1 over 3. Now later on we are going to talk at length about the signs in the different quadrants of the rectangular plane, but for the fourth quadrant we have seen that the sine, the cosecant, the tangent, and cotangent are negative ratios, whereas the cosine and its reciprocal secant are positive ratios, and that is going to be true for all angles in the fourth quadrant. Here is an example that shows us how to find the trigonometric ratios of quadrantal angles. What do we understand by a quadrantal angle? Any angle that is formed when the terminal side rests along the x-axis or the y-axis, whether positive or negative, is known as a quadrantal angle. The quadrantal angles are the 0 degree or the 0 radian angle, the 90 degree or the pi over 2 radian angle, the 180 degree or pi radian angle, and then we have the 270 degrees or 3 pi over 2 radian angle, and then of course 2 pi radian angle or the 360 degree angle. How do we go about finding the trigonometric ratios when the angle is on the quadrant? So let's read the question here. It says, evaluate if possible the cosine function and the cosecant function at the following quadrantal angle when theta is equal to 0 degrees or 0 radians. All right, I'm going to pull up the step-by-step process of doing that. So it says here, if theta is 0 degrees or 0 radians, then the terminal side of the angle is on the positive x-axis. So a 0 degree angle is formed when the terminal side and the initial side overlap along the positive x-axis. And they have chosen a point P on the x-axis with coordinates 1, 0. Now, when the point is on the x-axis, the y value will always be a 0, no matter what value x has, because there is no vertical movement. Y is always going to be 0. right? So what would be the value of r? Because to come up with the trigonometric ratios, we need to know x, we need to know what y is, and we need to know what r is. So we can find the value of r using the Pythagorean theorem. So r equals square root over x squared plus y squared. Therefore, r will be square root over 1 squared plus 0 squared, 0 for the y, 1 for the x, and we'll end up with square root over 1, which is a 1. So here we have x equals 1, y equals 0, and r is equal to 1. Correct? So given that, what would cosine of 0 degrees or 0 radians be? Cosine is x divided by r. So x has a value 1, r has a value 1, so it's going to be 1 divided by 1, which is a 1. So cosine of 0 degrees is going to be a 1. What about cosecant of 0 degrees? Now, cosecant is the reciprocal of the sine function and not the cosine function. Please be careful about that. Cosecant is r divided by y. Now, r has a value of 1, but y has a value of 0. We cannot divide by 0, therefore the result is going to be an undefined value. Cos of 0 degrees is a real number 1, but cosecant of 0 degrees or 0 radians is going to be undefined. And in this way, you can find the trigonometric ratios of all the other functions, sine, secant, tangent, cotangent as well. What do the ratios look like for a 90-degree or pi over 2 radian angle? The 90-degree angle is formed when the terminal side rests along the positive y-axis. And we pick a point on the y-axis, which is 0, 1. Now, no matter what y is, x is always going to be 0 for any point along the y-axis, positive y-axis or negative y-axis, because there's no horizontal displacement of that point, correct? We are going to work through this with the coordinates 0, 1, 0 for x, and y has a value of 1. What would the value of r be? You can run it through the Pythagorean formula and you will come up with r equals 1 as well. Let's look at what happens next. Cosine of theta is x divided by r. X has a value of 0. R has a value of 1. Therefore, the ratio has a value of 0. Now, we can divide 0 by any number. It gives us 0, which is a real number. However, we cannot divide any number by 0. For cosecant of theta, it's r divided by y. R has a value of 1. Y has a value of 1. Therefore, the ratio for cosecant of 90 degrees or pi over 2 has a value of 1. Now, let's see what the ratios are going to look like for a 180 degree or a pi radian angle. A 180 degree angle will have the terminal side resting along the negative x-axis. So if we pick a point on the negative x-axis, y is going to be 0 and x is going to be a negative value. So here we have chosen a point with the x coordinate being -1 and y is a 0. Now we can go ahead and calculate r. We will see that r is still 1, even though x is a negative value. So I'm doing the calculation here. I'm sure some of you have already figured it out. R equals square root over x squared plus y squared, which is square root over -1 whole squared plus 0 squared, which is going to be square root over 1, which is a 1. So we have a value of 1 for r. Now let's try to calculate what cos of 180 degrees or pi radians is. Again, it's x divided by r. X has a value of -1. Y has a value of +1. So negative divided by positive is -1. So cosine of 180 degrees is a negative ratio, -1. What about cosecant of 180 or pi radians? It's r divided by y. R has a value of 1. Y has a value of 0. So here we are dividing by 0. So of course the result is going to be undefined. So for a 180-degree angle or pi radian angle, cosine will be a real number, which is a negative number in this case, but cosecant is going to stay undefined. Let's see what happens for a 270-degree angle or 3 pi over 2 radian angle. A 270-degree angle is formed when the terminal side rests along the negative y-axis. And if we pick a point on the negative y-axis, x is always going to be 0 and y is going to have a negative value. So we've chosen -1. This point P has coordinates 0, -1. To find r, we can again use the Pythagorean theorem and we will see that r has a value of 1 in this case as well. So now that we have x, y, and r, we go ahead and calculate the ratios for cosine and cosecant, the ones that they are asking in this question. So cos of 270 degrees or 3 pi over 2 is x divided by r. X has a value of 0, r has a value of 1. 0 divided by 1 is 0. And that's a real number. For cosecant 270 degrees, it's r divided by y. R has a value of 1, y has a value of -1, so it's going to be 1 divided by -1, which is -1. So for a 270-degree angle or 3 pi over 2 radian angle, both cosine and cosecant are real number values, and cos has a value of 0 and cosecant has a value of -1. Depending on the quadrant in which the angle lies, trigonometric ratios may be positive or negative. Here we have a picture showing the different quadrants. There are 4 quadrants in the XY coordinate plane. In the anti-clockwise direction, quadrant 1, then quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, all 6 trigonometric ratios are positive. In quadrant 2, sine and its reciprocal, which is cosecant, are positive. In quadrant 3, its tangent and cotangent, which are positive values. Whereas in the 4th quadrant, cosine and its reciprocal, secant, are positive. And very often we remember this using the ASTC rule. A means all ratios are positive. Then in the 2nd quadrant, it's sine and its reciprocal, cosecant. T for tangent and its reciprocal, cotangent. And C for cosine and secant. This only gives the ratios which are positive in these quadrants. In quadrant 2, only sine and cosecant are positive. Everything else, like the cot, the tangent, the cosine, the secant, all would be negative in quadrant 2. Likewise, in quadrant 3, only tangent and cotangent are positive. Sine, cosecant, cos, and secant would be negative. So just remember the ASTC rule. 1st quadrant, all positive. 2nd quadrant, sine and its reciprocal, cosecant. 3rd quadrant, tan and its reciprocal cot, and the fourth quadrant cosine and its reciprocal secant. So that is how you can remember in which quadrant which ratio would be positive or negative. Let's work through an example of finding the quadrant in which an angle lies. The information given to us is that sine of theta is less than 0 and cos of theta is less than 0. That tells us that both the sine ratio and cosine ratio are negative values. We have to name the quadrant in which the angle theta lies. I'm going to use the ASTC rule, and I'm going to pull up the picture of our four quadrants here. The first quadrant is A, then we have S in the second quadrant, tangent, cotangent positive in the third quadrant, cosine and secant positive in the fourth quadrant. Based on this, let's try to determine where theta could be. In the first quadrant, all functions are positive. Here, sine and cosine both are negative, so it couldn't be in quadrant 1. Can it be in quadrant 2? In quadrant 2, sine is positive. The information tells us sine is negative, so it cannot be in quadrant 2 either. Let's look at the third quadrant. Here, tangent and cotangent are positive. Everything else is negative. This is where the angle in question would lie. Let's look at the fourth quadrant. In the fourth quadrant, cosine and its reciprocal are positive ratios, so it cannot be the fourth quadrant either. The only option is quadrant 3, and that is where the angle lies. So theta lies in quadrant 3. Let's go through another example for evaluating trigonometric functions given a different set of information. They've told us here that tan of theta equals negative 1/3. They've given us an exact value for tan of theta, and they've also told us that cosine of theta is less than 0. They haven't given us the exact value for the cosine function, but they've told us it's less than 0, so that's a negative ratio. For the tangent, they've given us the exact value, and we know that the tangent function is also a negative ratio for this particular angle, whatever it may be. So we have to go ahead and find the values of the sine ratio and the cosecant ratio. Now, the first thing that we can determine from this information is in which quadrant the given angle theta would lie. We will use the ASTC rule. It cannot be in the first quadrant because all ratios in the first quadrant are positive. Tan and cosine are both negative, so it cannot definitely be in quadrant 1. It cannot be in quadrant 3 either because tangent is positive in the third quadrant, so we can safely eliminate quadrant 3. It cannot be in quadrant 4 either because cosine is positive in the fourth quadrant. We've been told that cosine is negative for this particular angle, so that gets eliminated also. So we are just left with the second quadrant where sine and cosecant are positive. All other ratios, tan and cosine, would be negative. So the second quadrant is where the angle lies. Once we have established that, we are going to go ahead to solve this problem. So they've said because both the tangent and cosine are negative, theta lies in quadrant 2. So let's proceed. Tan has the ratio y divided by x. Now tan is negative 1/3. We can write a 1 for y and 3 for x, but there's the negative sign. To which variable do we assign the negative sign? That's the question we have to figure out. The negative sign should be with x, because think about it, if it's a second quadrant angle, the x values would be negative, correct? Second quadrant is here. All the x values would be negative and the y values would be positive. So we are going to assign the negative sign to x and keep y as a positive value. Now we got x equals -3, y equals 1, and we can find the remaining side r using the Pythagorean theorem. We should get a value of square root over 10, but let's just proceed to see what comes up as a solution for this. Here they have y equals 1, y will be a positive value, x will be a negative value. So now x is -3, y equals 1, and then using those values, they find the value of r using the Pythagorean theorem, and they too come up with square root over 10 for the value of r. Now to find sine, it's y divided by r. You just plug in the value of y, which is 1. R had a value square root over 10. We have to rationalize the denominator by multiplying both numerator and denominator by square root over 10, and we get square root over 10 divided by 10. For the cosecant ratio, it's the reciprocal of sine, so r divided by y. R has a value square root over 10, y has a value 1, so the cosecant ratio is simply square root over 10. Right? Let's talk about the reference angle at this point and try to understand what it is. It says here, let theta be a non-acute angle in standard position that lies in a quadrant. What is a non-acute angle? It's an obtuse angle greater than 90 degrees. What is an angle in standard position? An angle in standard position has the initial side resting along the positive x-axis. To find the reference angle for that angle, an obtuse angle in standard position, it would be the angle that is formed by the terminal side of that angle and the x-axis, be it the negative x-axis or the positive x-axis. So in this first picture here, we see this is an obtuse angle in the second quadrant greater than 90 degrees. It is in standard position because its initial side lies along the x-axis. So its reference angle would be the angle formed by the terminal side and the x-axis. How would we find the value of this angle? You just take 180 degrees and from it you subtract theta. So if this x-axis makes a 180 degree angle, we will know the value of theta. All we have to do is subtract theta from 180 degrees to get this acute angle. Reference angles will always be acute angles. Let's look at the second picture here. This is an angle in the third quadrant. Again, it's an obtuse angle, non-acute angle. It's in standard position with the initial side shown to lie along the positive x-axis. The reference angle of this would be the angle formed by the terminal side of theta and the x-axis. So here we have theta dash indicating the reference angle. Again, note that this is an acute angle. How do we find the value of this third quadrant reference angle? You just take the value of theta, the angle measure, and from it you subtract 180 degrees. You can get the reference angle for a third quadrant angle. A third quadrant angle would be a value between 180 degrees and 270 degrees. Let's look at a fourth quadrant angle in the third picture. It is a non-acute angle, clearly, and then it's in standard position. So for the fourth quadrant angle, the reference angle is this acute angle between the terminal side and the positive x-axis. How can we find the value of the reference angle for the fourth quadrant angle theta? Just take 360 degrees and from it you subtract theta, you will get this reference angle value. A fourth quadrant angle is an angle between 270 degrees and 360 degrees. Here's an example of finding reference angle using the formulas that we just learned. It says find the reference angle denoted theta dash for each of the following angles. The first one is 210 degree angle. So we have to first determine in which quadrant a positive 210 degree angle would lie. It's a third quadrant angle, an angle between 180 degree and 270 degrees. The formula for that was theta minus 180 degrees. So let's see if that's what they have done here to find the reference angle of 210 degree angle. Yes, the reference angle formula is theta minus 180 degrees. So we plug in 210 degrees for theta and we get a value of 30 degrees after subtracting 180 degrees from 210 degrees. The next one is an angle given to us in radians, 7 pi over 4. This is a fourth quadrant angle. 7 pi over 4 is just pi over 4 less than 2 pi, correct? So this is the angle in fourth quadrant. The formula for that would be 2 pi. The degree equivalent of that was 360 minus theta. We're going to replace 360 with 2 pi because we are dealing with radians here. So 2 pi minus theta, so it should be 2 pi minus 7 pi over 4. It should give us a reference angle which is pi over 4. The third one is a negative angle. How do we find the reference angle of negative angles? We have to first find the coterminal angle. So first, of course, we have to determine in which quadrant the negative angle lies, and then we have to look at the coterminal angle and then apply the formula. Negative 240 degrees would be an angle in the second quadrant. This is our negative 240 degrees by moving the terminal side in the clockwise direction, and its coterminal angle is going to be 120 degree angle, which you find by subtracting negative 240 from 360 degrees. So the coterminal angle is 120 degrees, and once we know the coterminal angle, the reference angle is going to be the angle between the x-axis and the terminal side of the angle, correct? This angle. So you're going to use the formula 180 degrees minus theta. I'm going to write here the formula for this is going to be 180 degrees minus theta, but theta here is the coterminal angle of theta, and we should get an answer which is 60 degrees. 180 degrees minus 120 degrees should give us 60 degrees. The fourth one here is theta equals 3.6. The way we are going to do that 3.6, we go theta minus pi, which is 3.6 minus 3.14, which is equal to 0.46. How did we know that to find the reference angle we should use the formula theta minus pi? We know pi has a value 3.14. 3.6 is going to be an angle in the third quadrant, and a third quadrant angle will have the formula theta minus pi, and that's how they came up with this number 0.46. We are now going to learn how to find the reference angles for angles greater than 360 degrees or 2 pi or less than negative 360 degrees or negative 2 pi radians. Now the main idea here is to find the positive coterminal angle if the angle has a measure greater than 360 or less than negative 360 or its equivalent in radians. And once we get the coterminal angle, we are going to draw the angle in standard position, and then we are going to find the positive acute angle formed between the terminal side and the x-axis, which would be the reference angle. Let's work through an example in the next slide. Let's work on some examples of finding the reference angle of angles which are greater than 360 degrees or 2 pi radians or less than negative 360 degrees or negative 2 pi radians. We'll start with the first angle given here, 665 degrees. The first step would be to determine in which quadrant the 665 degree angle would lie. So I'm going to draw the angle in the standard position. This is a positive angle, so we are going to move in the counterclockwise direction. We have to go one cycle up to 360 degrees, and 665 degrees is greater than 360, so we have to move around again and stop somewhere in the fourth quadrant, and that is where the angle is going to lie. We have the 665 degree angle in the fourth quadrant after going over one cycle in our rectangular coordinate plane. The next step would be to find the coterminal angle, which is an angle within 0 and 360 degrees. So I've indicated here in blue, and that is going to be our coterminal angle. The way we find the coterminal angle is we subtract 360 degrees from 665 degrees and we get a value of 305 degrees. So this blue angle is 305 degrees, and that's really the coterminal angle. They have shown here a picture of the angle. Right here, they have a 305 degree angle, which is the coterminal angle, and the reference angle is going to be the angle between the terminal side and the positive x-axis. So this angle here is our reference angle. For fourth quadrant angle, the formula to find the reference angle is 360 degrees minus theta, which is the coterminal angle, and when we do the subtraction we get an angle measure of 55 degrees. So that is what the reference angle is. Let's go on to the next example. It's an angle given to us in radians, 15 pi over 4. So again, we are going to start by drawing the angle and determining in which quadrant the angle will lie. This is again a positive angle, so we are going in the counterclockwise direction, complete one cycle and then continue around to the fourth quadrant. 15 pi over 4 is 1 pi over 4 less than 16 pi over 4, which is 4 pi. That's why we do not complete two cycles, we stop in the fourth quadrant. So 15 pi over 4 is also a fourth quadrant angle. Let's write 15 pi over 4, and now we have to find the reference angle, which is going to be an angle measure within 2 pi. The way to go about finding the coterminal angle in this case is take 15 pi over 4 and from it we subtract 2 pi. And that should give us a coterminal angle measure of 7 pi over 4. Once we have the coterminal angle, we can find the reference angle, which is this angle between the terminal side and the positive x-axis. The formula to find that is the reference angle formula, 2 pi minus 7 pi over 4, which is the coterminal angle, and that should give us a value of pi over 4. So if you look at the solutions now, they pretty much do the same thing. They've used 7 pi over 4, which is the coterminal angle. They haven't shown the steps of finding the coterminal angle, but they have used that and subtracted it from 2 pi to get a reference angle angle value of pi over 4. For the third problem here, now this one is a negative angle. Let's show in which quadrant the negative angle would lie. This being a negative angle, we will be moving in the clockwise direction from the positive x-axis. We go around one cycle and then go around again and come and stop in the first quadrant. Here's our angle, which is negative 11 pi over 3, which we formed by moving in the clockwise direction. Find the coterminal angle now. The coterminal angle is this angle here. Let's write the formula. Coterminal angle would be minus 11 pi over 3 plus 2 pi. And that would give us an angle measure of negative 5 pi over 3. So this angle here is really negative 5 pi over 3, the coterminal angle. And once we have the coterminal angle, we can find the reference angle, which is by taking the negative 5 pi over 3 and adding 2 pi to it. The reference angle here is the angle between the terminal side and the positive x-axis. So that should give us a value of pi over 3. Once we pull up the solutions here, this is what it looks like. They took the negative 11 pi over 3 and they did a little bit differently. They added 12 pi over 3 to it, which is 4 pi, and they got an answer of pi over 3, which is the same as what we got. So this is how we can go about finding the reference angles for angle measures greater than 360 degrees or 2 pi or less than negative 360 degrees or negative 2 pi. Now let's go about evaluating trigonometric functions using the reference angles. If we can do that, then we will not be needing calculators to find the trigonometric ratios. Now the trigonometric functions of a given angle theta are going to be the same as the values of the trigonometric functions of the reference angle. The only thing that's going to be different is the sign of the ratio, and we can determine the sign of the ratio if we know in which quadrant the particular angle theta lies. So a function value of the acute reference angle is always positive, but it's the sign that may be positive or negative, and we can use the ASTC rule to determine what the sign is going to be depending on the trigonometric function that we are finding. Here they have given us a two-step procedure for evaluating trigonometric functions using reference angle. In the first step, we find the associated reference angle of theta, the angle given to us, and then we find the trigonometric ratio of the reference angle theta dash. In the second step, we determine in which quadrant the original angle theta lies. We use the ASTC rule to figure out what sign, positive or negative, goes with that particular trigonometric function that we are finding, and we just prefix that sign to the ratio we found in step 1. Let's go through an example that shows how we can use reference angles as well as the ratios of special angles to evaluate the trigonometric functions of angles which are not necessarily special angles. The first question here says use reference angles to find the exact value of sine of 300-degree angle. Now we know that 300-degree angle is in the fourth quadrant. So if I draw the 300-degree angle in standard position, it's a positive angle, so it will be formed by moving the terminal side in the anti-clockwise direction. 300 is 30 more than 270. This is where the angle is going to be in the fourth quadrant, correct? This is our 300-degree angle. Next step, we are going to find the reference angle for this 300-degree angle. Again, the reference angle is an acute angle formed by the terminal side and the x-axis. So this angle here between the terminal side and x-axis is going to be our reference angle. For a fourth quadrant angle, the formula to find the reference angle is 360 minus theta. What is theta? It's 300 degrees for this example. So 360 minus 300 is going to give us 60 degrees, correct? So the reference angle is 60 degrees. Now we know that 60 degrees is a special angle. The sine of a 60-degree angle is square root over 3 by 2. So sine 60 degrees is square root over 3 by 2. However, the angle in question is 300 degrees, which is a fourth quadrant angle. In the fourth quadrant, the sine ratio is negative by ASTC. Sine is negative in the fourth quadrant. So all we do is append the negative sign before the ratio. Instead of writing it as square root over 3 by 2, it's going to be negative square root over 3 by 2. So it's negative sine of 60 degrees for sine of 300 degrees. So essentially, sine of 300 degrees equals negative sine of 60 degrees, which is equal to negative square root over 3 by 2. Now I'm going to pull up the solutions here and go through their steps. So first step is find the reference angle and sine of theta. So the reference angle is going to be 60 degrees. So reference angle is 360 minus theta because this is a fourth quadrant angle. That's the formula we should be using. 360 minus 300 equals 60 degrees is what we had done here. And then we use the quadrant in which theta lies to prefix the appropriate sign to the function value in step 1. Let's see how they do that. Sine of 300 degrees equals negative sine of 60 degrees is what we had here, which is equal to negative square root over 3 by 2. Let's look at a second example of finding the exact value of tan of 5 pi over 4. This time the angle given to us is in radian measure. We first have to determine where 5 pi over 4 is. It's a positive angle. In standard position, it would be an angle in the third quadrant. 5 pi over 4 is greater than pi. So it's going to be an angle in the third quadrant. This is 5 pi over 4. So for a third quadrant angle, the formula to find the reference angle is theta minus pi, or theta minus 180 degrees. So our theta here is 5 pi over 4 minus pi would give us pi over 4. So the reference angle, which is the angle between the terminal side and the x-axis, is going to be pi over 4. Now we know that tan of pi over 4 is 1, and the angle being in the third quadrant is positive because, again, according to the ASTC rule, tangent is positive in the third quadrant. So we can write this as tan of 5 pi over 4 is equal to tan of pi over 4, which is equal to 1. So let's go through the steps one more time here again. First step is find the reference angle, and there's a problem here. This is not sine of pi, sine of the reference angle. It's the tan of the reference angle. That's what we are finding here. So next step is the reference angle formula, which is theta minus pi, and then we have the reference angle calculated as pi over 4, exactly what we got here. And now we have to use the quadrant in which theta lies to prefix the appropriate sign to the function value in step 1. And tan of 5 pi over 4 will be equal to tan of pi over 4, which is equal to positive 1. We don't have to worry about prefixing the negative sign here because this is a third quadrant angle and tan is positive in the third quadrant. Let's consider one more example, this time to find the secant of a negative angle, which is negative pi over 6. The first step is to find the reference angle of negative pi over 6 using the formula of adding 2 pi to the negative angle. And that's what they have done here. We get a reference angle value of pi over 6. In the next step, we are going to find the secant ratio of pi over 6, and then we are going to determine in which quadrant negative pi over 6 lies, figure out the sign, positive or negative, that goes with secant in that quadrant and prefix that to the ratio. So secant of pi over 6 has the ratio 2 times square root over 3 divided by 3. Now secant is the reciprocal of cosine. So if we have our angle, negative pi over 6 is a fourth quadrant angle, and by the ASTC rule, both cosine and its reciprocal secant would be positive in the fourth quadrant, and therefore we leave the ratio with a positive sign 2 times square root over 3 divided by 3. Correct?